The next topic is Y parameters. Similar to Z parameters, the Y parameters also tell us about the circuit. Parameters like input admittance or output admittance or transfer admittance, something like that. Okay, so these are the two basic equations. One is, so here, the first one is I1 equal to Y11 V1 plus Y12 V2, and I2 equal to Y21 V1 plus Y22 V2. So here I1 and I2 are dependent quantities, V1 V2 are independent quantities. Okay, so based on this, similar to Z parameters, Y11 is admittance, short circuit input admittance. When you see short circuit, that indicates that the other quantity voltage is 0. So voltage across short circuit is 0. So here it is 0 volts. So that's the reason we are saying short circuit input admittance. So Y11 equal to I1 over V1 when V2 equal to 0. So we are making V2 equal to 0, that is nothing but short circuit. And Y12 short circuit transfer admittance from port 2 to port 1. Y12, which is I1 over V2 when V1 equal to 0. Y21 I2 over V1 when V2 equal to 0. Y22 I2 over V2 when V1 equal to 0. So if you look at these two quantities, Y12 and Y22, these two quantities, we can find them together in one circuit. Same thing with Y11 and Y21. These two quantities, we can find them together with one circuit. Okay, so now if Y12 equal to Y21, if Y12 equal to Y21, similar to impedance parameters, we call that network as reciprocal network. Okay, it is called reciprocal network. Similar to Z parameters, if Y12 equal to Y21, then we can represent that network with a pi equivalent network. If it is a reciprocal network, then we can represent the network. We can represent the given circuit as pi equivalent circuit or network, pi equivalent network. Okay, I'm going to start solving an example. Here is a simple example. I forgot to mention the unit. The units for admittance is Simons. Okay, we indicate with S. Okay, here is a simple example. In this example, he's asking about finding the Y parameters. We know that, so I'm going to choose always, it doesn't matter whether Z parameters or Y parameters, we always choose this as I1 entering and also I2 entering and V1 and V2. So all I know, Y11 equal to I1 over V1 when V2 equal to 0. Same way, Y21 equal to I2 over V1 when V2 equal to 0. So basically, to find these two parameters, I have to make V2 equal to 0. So that means I need to short circuit that. Okay, so still here is my I1, V1, here is my I2. Okay, so to find I1, can I say these two are in parallel? So 4 parallel with 6, which is 2.4. 4 times 6 divided by 4 plus 6, that is 2.4 ohm. Okay, and that is 2 ohm. So can I say, so it's basically something like this: 2.4 ohm and 2 ohm. I don't have this branch. Okay, here is my I1 and V1. So can I say my Y11 equal to I1 over V1? So in this case, can I say V1 equal to 4.4 I1? So Y11 equal to I1 over V1, which is 1 over 4.4, which is 0.227 Simon. Okay. Now, by using the same circuit, we can find Y21. Y21 equal to I2 over V1. So in this circuit, can I say in this given circuit, I1 is coming here? Can I say this I2 by using current division rule? Negative total current opposite resistance over total resistance. So I1 is dividing into I2, I mean negative I2, and some current IY. Okay, so to find this I2, negative I1 times opposite is 4 ohms divided by 4 plus 6. Okay, so I2 equal to minus 4I1 over 10. So I'm going to replace I1 with in this equation. I'm going to replace I1 with I1 equal to 10 I2 over 4 negative. So if I replace this here, V1 equal to 4.4 I1, which is 4.4 times negative 10 divided by 4 I2. Okay, so Y21, which is I2 over V1, which will be what is that value? 4 divided by negative 44. That value equal to minus 0.0909 Simon. This is Y21. Now I'm going to find the remaining two parameters here. So to find remaining two parameters, so let me draw the circuit again. So the remaining two parameters, Y12 and Y22, equal to I2 over V2 when V1 equal to 0, and I1 over V2 when V1 equal to 0. So in both cases, V1 equal to 0, so we're going to short circuit V1 in this case. So here is the circuit. I draw the circuit. My I2, V2, and here is my I1. Okay, now I'm going to find Y22 first. To find Y22, I can say these two are in parallel. 4 parallel with 2, which is 8 over 6, which is 1.33 ohm. Okay, so now I have 1.33 times or plus 6. So here is my I2 and V2. Can I say V2 equal to 7.33 times I2? So Y22 equal to I2 over V2, which is 1 over 7.33. That value is 0.136 Simon. Okay, now the last term, I'm going to find Y12, which is I1 over V2. Okay, so I already have this equation, so I need to find a relation between I2 and I1. So I know I2 is coming here, it's going to split. So can I say I1 equal to negative I2 times opposite over total, 2 plus 4. So negative I2 times 4 over 6. So if I replace this I1 here, I1 in this given equation, so V2 equal to 7.33 times 4 over 6 times negative I2. So that will give us Y12 equal to, okay, so look like I made a small error here. Let me replace this. Okay, so here, so I need I1, right? So I2 equal to minus 6 by 4 times I1. Okay, now I'm going to replace I2 here. So V2 equal to 7.33 times minus 6 by 4 I1. Okay, so V2 equal to minus 10.995 I1. So if I substitute those quantities here, I'll end up with Y12 equal to I1 over V2, which is negative 1 over 10.995. That value is minus 0.00909 Simon. So if I look at the Y parameters, I have Y11, 12, 21, 22, Y22 parameters. So I'll end up with Y11 equal to 0.227 Simon, Y12 minus 0.0909 Simon, Y21 minus 0.0909 Simon, and this value Y22 is 0.136 Simon. Okay, now in this case Y12 and Y21, they are same, so we can draw an pi equivalent circuit. So when we draw the pi equivalent circuit, this is how the pi equivalent circuit is going to look like. So here is your I1, V1, V2 and I2. This value is negative Y12. This value is Y11 plus Y12. This value is Y22 plus Y12. Okay, so now you can replace these quantities with the given ones. So this value is minus 0.0909 Simon, and this value is 0.136 Simon. This value is 0.009